Welcome to this lecture. In this lecture, we will learn about ArrayList and its methods. This is the first practical session of this course. I am sure many of you are eagerly waiting for this session to start. As you can see here, I have opened IntelliJ IDEA. Let's create a new project by clicking on this New Project button. In this page, we can specify Java version. We have downloaded the Java version 9 and we attached that version into IntelliJ IDEA. That's why Java version 9 is shown here. If you would like to add new JDK, you can always add new JDK by clicking this option. If you would like to add a new version of JDK, you can download them using this option. I'm leaving as Java 9. I'm clicking next. We are not creating project from template, so we can skip this page. In this page, we need to provide project name. I'm going to type in the project name. ArrayList Demo 1 is the project name. Then clicking finish, this will create the project. The project has been created. As you can see on the right side, the project is available. Now let's see the project structure. These are the project files. We need to write our code on the source folder. I am right clicking on this. Here we have many options here. For this demo, first we need to create a Java class. We can go to this new option. Now we have Java class. Before that, first let's create a package. Let's provide a package name. The package name has been created. Now let's right click on this package and create a new class. Java class here. Now let's provide a Java class name. The Java class name is given as ArrayList Demo. Click enter. As you can see here, the ArrayList Demo class has been created. Now let's create the main method. The main method has been created. We have discussed in the previous lecture that there are 3 constructors available for ArrayList. Now we are going to create an ArrayList using the first and the empty constructor. Now let's create an ArrayList using that constructor. ArrayList. It will load java.util.ArrayList package. Now I am going to create an ArrayList of strings. I am going to insert the month of an year. The ArrayList has been created. As you can see here, this ArrayList is of type string. I am going to insert the months of an year, such as January, February, March, and so on. Now let's try to add the element. There are 2 overloads available for add method. The first one accepts an index and it inserts the data at a specified position, while the second one always adds the element at the end of the list. I'm going to copy paste these three to create 12 months. Now I'm going to edit these months, April. Now I have inserted all the month names. Now let's take the ArrayList size using size method. The expected output is 12 as we have inserted 12 month names. We can print using system.out.println. To run this program, right click, then click Run ArrayList Demo.main method. The program ran successfully. As you can see here, the size of array is 12 as expected. When we are adding an element using add method, this version of add method adds an element at the end. Now let's try to add in between elements. I am going to add October. October sits at 9th position because array list indices start from 0 to 11. So let's insert October at 9th position. Now the number of elements in the array list is 13. Let's check the size of the array. Yes, as you can see here, the size of the array is 13 now. Now let's try to print the elements of this array list. I am going to use the default version such as ArrayList.toString method. Let's see how it displays the array elements. As you can see here, this is how the toString method of an array list displays its elements. We don't need to call toString method. By default, when we are printing array list using system.out.println, system automatically calls toString method. Now let's rerun this program. As you can see here, the output is not changed. Have you noticed this? The element October has been duplicated. Because here using this line, we are adding one more element, such as ArrayList accepts duplicate elements. Now let's try to remove this October element using remove method. And let's see how this ArrayList behaves. When we are removing October, what will happen? Because there are two Octobers, which one will get removed? Will this method remove all of them or just the first occurrence? Let's find out. As you can see here, the element October is removed only once. The remove method removes only the first occurrence of an element. To remove all the elements, we have to use a different logic. Let's try to remove all the Octobers using remove if method. As you can see here, the remove if method accepts a predicate filter, such as it performs an operation. Now let's see how this works. We can pass a predicate function here, and these predicate functions are specially built for lambda operations. So let's write a lambda condition. This is the condition that we have written. Now the method filter is not yet created yet. We can create that method. It is going to be a boolean method, such as if this method returns true, then that element will be removed from the array list. Now if I am returning true from this function for all the elements, then all the elements will be removed. Let's see how it works. As you can see here, all the elements has been removed from the list. Now let's try to remove only if the element is October. Now let's rerun the program. As you can see here, only the October has been removed from this list, because each element will be passed to filter, and filter checks whether the element is equal to October or not. If it is October, it returns true, else always returns false. This code can also be rewritten as a single line, such as we can rewrite this method as shown here. Now let's run the program. As you can see here, the same output. Now since we have only one line, it is not mandatory to create a new method as filter. We can directly place it here. Now I am going to remove this method since it is not used. As you can see here, the same output. The remove if method, sort method, and for each method are similar. Now let's see how sort method works. I am going to remove these three lines. Now let's see how the sort method works. See, just like remove if method, the sort method also accepts a comparator interface. Let's create a comparator, similar the way we have created filter method for remove if method. The comparator accepts two objects for comparing. For remove if, we passed only one parameter, but comparator accepts two, so we have to create two objects here, such as s1 for string 1 and s2 string 2. Now let's create this compare method. As you can see here, the compare method returns an integer value based on the comparison. Now let's compare the two strings. This comparison is for alphabetical order. Now let's run this program. As you can see, A, D, F, the months have been arranged according to the alphabetical order. Now to reverse this order, we just have to change this logic. As you can see here, the month names has been reversed. This is how sort works. There is one more way to sort an array list. We can use collections class to sort an array list. We will learn about collections class and its method later in this course. Now let's comment out this line and rerun the program. As you can see here, the array list is sorted. Now let's check for each method. I am removing these two lines. As I said before, remove if, sort and for each method work similar. As you can see here, for each accepts a consumer action. Here E stands for element. You can give any value here. You can give X, you can give P, anything you can give. But you have to make sure that this parameter and this parameter are always same. Now let's create an action. If we have noticed, remove if method returns boolean value. Sort method returns an integer value. But action is of type void. Now let's try to print this element. I'm going to comment out this line and rerunning the program. As you can see here, the elements has been displayed in new line. For each element, Java calls action method, and in action method that element has been passed. Then you can perform your application logic on that element. Here action method does not return anything. Now let's check index of, last index of and contains method of ArrayList. I am removing this code just to grab some space. The index of method accepts an element and returns its position from the array list. Now let's see an example. I'm running the program. As you can see here, the position of July is 6, which is right, because indices of array list start from 0. If there are duplicate elements and if you like to find the last occurrence of that element, one can use last index of method. Since the element July is unique in this list, the position will be same as before, which is 6. Now let's add a duplicate element of July. I have added an element of July. Now the element July is duplicated. Now let's check the last index of July. As expected, this is tall. Now there is one more method which can check the existence of an element, such as contains method. Now let's see how contains method work. As you know, contains method returns boolean value. Let's create a boolean variable. Now let's run this program. As you can see the output, the element December exists in the array list. Hence, the contains method returns true. Now let's provide an element which does not exist in the array list. There is no month named ABC. Now let's see. Now let's rerun the program. As you can see, the contains method returns false, and the respective print line is printed. I am free to discuss about replace all method, which is similar to remove if, sort, and for each methods. Now let's see how replace all method works. I am removing this part of code just to grab some space. As you can see here, replace all acts as a unary operator. Let's see how this operator can be created. It is created using lambda syntax. I'm going to create this replace data method, which accepts an element and returns the same type of that element, which is string. I'm going to trim out the string. Now let's see the output. As you can see here, we are considering only first 3 characters of a month. By using replace all, we applied this logic on each element of a list. Now let's discuss about sublist and remove all methods. Remove all method works with a collection. So first let's create a new collection, which is of first 6 months of an year. Let's create this new collection using the second constructor which accepts a collection. I'm going to create an array list using a second constructor. First 6 months. Now we are going to learn a new method such as sublist. Sublist can return a portion of an array list using from index and to index. Let's pick first 6 elements using sublist. Now we have created a new collection called first 6 months. Now let's see how remove all use of this collection. Now let's run the program. As you can see here, this line trimmed first 6 months from the list. Now let's learn about iterators. We have a dedicated section available for iterator later in this course. But let's see how we can obtain an iterator object. This is how we obtain an iterator object. Using Iterator Object, we can traverse an array list. Let's see the methods of an iterator. As you can see here, we have methods for each remaining hash next, next and remove methods. Similar way, we can generate and list iterator. This is how we obtain list iterator. As we discussed earlier, list iterator is preferred when we are working with a list because it has some special methods such as this: add, hash next, previous, hash previous, previous index. These methods are helpful when we are traversing in ascending order and in descending order. This is why list iterator is more preferred when working with listers. Similar way, we can obtain splitterator as well, and splitterators are very useful when working with Stream API or parallel programming. This is how we obtain the object of a split iterator. Anyway, we will discuss in detail about these iterators in the upcoming section. Iterators provides better control over the elements of a collection. Until we learn iterator, we can use for each loop to traverse a collection. Now let's see how for each loop works. I am removing this piece of code. This is the syntax of for each loop. Here string is the type of the data that an array list holds, such as this array list is holding string elements. Hence we can give string here, and this f is a placeholder, and this is the array list that we are going to traverse. Now let's print the elements of an array list. I'm going to comment out this line and rerunning the program. As you can see, the element has been displayed. We have an additional element here. I am going to remove that. Just rerunning again. For each loop is very helpful in many situations. And for each loop can be used with all type of collections and even arrays. Now let's learn about toArray method. There are two versions for toArray method. One is with an empty parameter, while the second one is with one parameter. Now let's see the first one. First one returns an object array always. Now this will return an object array. To print the items of the object array, we can use object here. Object is the type of the data available in this array. As you can see here, the data has been printed. Now there is one more option. I would like to return this data in a string array. For that, first I need to create a new string array, which is the size of an array list. Now I have created a new array named string array, which is having the size of array list. Now let's pass this array to toArray. When this line is executed, the empty string array is passed to toArray, but the array list returns the string array with the strings. Now let's print the strings. This string array contains string object, so let's add string here. As you can see here, the data has been printed. ToArray methods are very useful when collections working with arrays, and especially this version of ToArray method is very useful. Now let's see how to create a stream object. ArrayList provides a method called stream, which returns a stream object. And these stream objects are very useful when one is working with Stream API. Now let's discuss about clear and isEmpty method. If ArrayList is not empty, then clear the ArrayList. Clear method will clear all the elements from the array list. Now let's print out the size of the array list. It should print as 0. I'm running the program. As you can see here, the array list size is 0 now. We now learned almost all the methods of array list. There is one method which I intentionally left out, which is retain all method. I suggest you to practice with it. I hope the discussion of array list was really helpful. Now let's move to linked list class.